Now for a perpendicular bisector, if we have a line AB a line that is perpendicular to the line AB is a line that passes through and creates a 90-degree angle to the line AB. Now we know that from perpendicular lines have a gradient that is the negative reciprocal. So for our gradient, which we usually write m we know from this equation, once we are given 2 points. Right? So if you wanted to find the gradient of the line A, B, given the points A is -1 and 4, and B points 3 and 2, then it'll just be a matter of choosing whether or not the point A would be x2, y2, or x1, y1, and B the opposite, whether it be x1, x2, or x2, y2. So the perpendicular bisector, now bi means 2, so that means that we're cutting the line AB at the half midpoint. So this point here, let me draw that in another color. This point here is the midpoint, right? And we know the equation for our midpoint is given by x2 plus x1, or x1 plus x2, doesn't matter, d, right? And then the y coordinate would be y2 plus y1 over 2. Yeah, this is the midpoint. Yeah, that's the midpoint. So a perpendicular bisector cuts a line at the midpoint and is perpendicular to the gradient of the line. And we know that for perpendicular lines, the gradient, so if the gradient of AB sorry, so get my pen out. If the, oh my gosh, sorry about that. So if the gradient, yeah, the gradient of AB is m1, then for a perpendicular line to AB, the gradient, right, so the perpendicular bisector gradient would be m2, where m2 is equal to the negative reciprocal. So a reciprocal is the inversion of whatever it is you're looking for. So the inverse of m1, or 1 over m1, this is the inverse here, and then it's the negative reciprocal, as I mentioned before. So that's how you find the gradient of the perpendicular line to AB, right? And now that we have a point, which is the midpoint of that perpendicular line, and we have a gradient, we can easily determine the equation of the line. As in before, let's switch the color back to black. So we have a point and we have a gradient, right? So the gradient of the perpendicular bisector would be 1 over the gradient of this line. And okay, let's find the gradient of that line before we move anything. So here, the gradient of that line would be, let's go with, this is my x2, y2. Sorry, I'm using a trackpad, it's not the best. All right, and then this would be x1, y1, doesn't matter the difference. Yeah, so when we're finding the gradient, I guess I can do the gradient somewhere here. I'll just draw a little box here. So using this equation here, we have y2, which is 4, minus y1, which is 2, over negative 1, which is x1, minus 3. Okay, so now we have 2 over negative 1, negative minus 3 is negative 4. Right, so we have negative 1 over 2. Okay, great. So in order to find the gradient, so the gradient of AB is negative a half, or negative 0.5 if you will. And so to find the gradient of the perpendicular bisector, we have to find the negative of M1, which is, sorry, right, which is, okay, let's draw a bracket here. This is M1, which is what we just determined. This is M1 is equal to this, right? So when we find, so what we do is invert it, so the answer becomes 2. If we invert this here, we'll get 2, and then find the negative of that, it'll be a negative negative, so we get 2. I'm just writing another color. We get 2 for the gradient of the perpendicular bisector. So now we have our midpoint and a gradient. Well, we don't have the midpoint yet, but we can find that that would be x2, which is minus 1 plus 3, which will give me, sorry. Well, let's find the gradient. Right? Sorry, the midpoint. So the midpoint I'll just call M this. It's gonna be, let's look back at what I chose here. So it's minus 1 plus 3 over 2. That's a 2 here, just in case you, that's a 2. And then we have 2 plus 4 over 2. And just make this 2 look a little bit more presentable and not like a Z. Yeah. So negative 1 plus 3 will give me 2. So this one will be 1 for the x-coordinate. And 2 plus 4 is 6, divided by 2 is 3. So the midpoint is 3. So then we have, my bad. we have our midpoint for the perpendicular bisector, and I said before in the previous video that once we have a point and a gradient, we can easily find the gradient, the equation of the line. That my bad. So all right, so let's choose this point here, and we know our gradient is 2, so let's choose this point. So y is 3. We're plugging it into the equation. Y is equal to mx plus c, right? So we have we have 3. It's equal to the gradient, which is 2, x, which is 1, plus c. Okay. So c, making c the subject of the formula, will be 3 minus 2, which is equal to 1. Therefore, our equation of the line will be y is equal to 2x plus 1. Yeah? Okay. Thank you.